right, 4.1, day 2, we're still talking about exponential functions. So objectives of this part of the lesson are we're going to evaluate functions with base e, and we're going to use compound interest formulas. So the natural base e, it says a number e is defined as a value that 1 plus 1 over n, all raised to the nth power, approaches as n gets larger and larger. So as n goes towards positive infinity, the approximate value of e to 9 decimal places is written there. So the irrational number e is approximately 2.72, and it's called the natural base. The function f of x equals e to the x is called the natural exponential function. All right, so e is kind of like pi. It's just an irrational number that's approximated to be 2.72, like pi is approximated to be 3.14. Okay, it's just our natural base. So anytime you see something involves an e, it's talking about a natural base. But we don't work anything any different other than I'm going to let you just use your calculator on them, because with it being irrational, it's not going to be quite so easy to work out. All right, so example 1 here says the exponential function f of x equals 1145 e to the 0.0325x models a gray wolf population of the western Great Lakes. F of x years after 1978. Project the gray wolf's population in the recovery area in 2017. All right, well, like we always do, they gave us an equation, so let's pull it out and let's look at it. Remember, we need to identify what our variables are. So what is this f of x? Well, let's see. It says f of x right here. Now, after it, it talks about x years. So it must be the information before it. And the information before it says it's the gray wolf population. So we're just going to say that this is our wolf population. All right, what is x? Well, we see it's x years after 1978. So x is the years after 1978. Remember, when it says after, that means we're probably going to have to subtract 1978 from something. All right, so what is the question? So the question says, project the gray wolf's population, so we're after this, in the recovery area in 2017. So that means our year is 2017. Now, x is the years after 1978. So we're going to take that 2017 and subtract the 1978. And when we do that, we're going to get 39. So we're going to plug in 39 for our x value so we can solve for our gray wolf population. All right, so we got f of x equals 1145 e to the 0.0325 times 39. Now be really careful when you go to put this in your calculator, okay? So you're going to type in your 1145. Now that e, the easiest one to use because it'll raise it to an exponent for us is if you go to second, and if you look just to the left of your 4-digit, it has an ln, and right above it, it says e to the x. So let's choose that. And so it will have, it says e raised to, and then you need to put the 0.0325 times the 39. All right, so when we do this, I got 4,066.996. which is approximately, because we're talking about the population, we can't have a piece of a wolf. So I'm going to go ahead and round it up, because the 9 would make the 6 go up here to the whole number. But some places, some people will be like, because it's not a full wolf, you don't count it. So if you put 4,066, that would be acceptable as well. So either one of those two answers would work. So I almost forgot to label it there. So 4,067 gray wolves. All right, formulas for compound interest. After t years, the balance A in an account with principal P and annual interest rate R in decimal form is given by the following formulas. And so if you'll notice, the first formula is when it has n compounding periods per year, and it's A equals P times 1 plus R over n, all raised to the nt. Or number 2 is when it says continuous compounding, okay, and it's A equals P times E raised to the RT. Now, and I'll call that one PERT when I refer to it, just because it has PE and then RT. All right, so if it tells you it's compounded a certain amount per year, you're going to use the first formula. If it says the word continuous, it's compounding continuously, it has continuous compounding, something like that. It's got to have the word continuous, you're going to use that second formula. So let's go back through the variables, okay? Because I gave us kind of a technical definition here. Let's break it down. So A is going to be our ending amount. P is the principal, it's our beginning amount. And just so you know, A is for accrued value, that's why it's an A. All right, R is the rate as a decimal. So they're usually going to give us the rate as a percentage. So we're going to move the decimal place 2 places to the left, or we can divide by 100. Give us the same thing. T is going to be your time in years. So watch out for that, because they might tell us it was 18 months, which means it's 1.5 years. It's a year and a half. Okay, and then N. N is the number. Let me write it out. Of times compounded per year. All right, and some of the ones that they're going to give us, they could say the word annually. If they do that, then our N is equal to 1. It's 1 time a year. If they say semi-annual, that's twice a year. They could say quarterly. That's 4 times a year. Monthly. It'd be 12 times a year. They could say, was it weekly? That's 52 times a year. Let's see what's another. Oh, daily. If they say daily, then we say N is 365, unless they tell us different on daily, okay? So use daily as N is equal to 365. Every now and then you hit one that wants to be weird, and they'll say, like, let the number of days, let it be 360 or something. So if they tell you different on daily, then use what they tell you. Otherwise, this is what we use. And I think that's all the ones we really see. Just to kind of remind you of that. All right, so example 2 says a sum of $10,000 is invested at an annual rate of 8%. Find the balance in the account after 5 years subject to quarterly compounding. Okay, so that tells us that we're going to use, because it doesn't say continuously compounded, it says quarterly. So that's the first formula. So we're going to use the fact that A is equal to P times 1 plus R over N raised to the NT. So let's go and figure out what all of our numbers represent. So it says a sum of $10,000 is invested. That's how much we're putting in at the very beginning. So that is our P. At an annual rate of 8%. So our R is 8%, but remember we want it as a decimal, okay? So if I divide 8 by 100, I get 0.08. It says find the balance after 5 years. So find the balance means we're looking for that ending amount. After 5 years, so T is going to be 5. Quarterly compounding. Well, that means quarterly means it's compounded 4 times per year. So N is going to be 4. And so we're just going to plug this in. Just be careful when you go to put this in, especially with that exponent, since it has more than one number up there. If you wanted to, sometimes it's just easier to go ahead and multiply them. We know that 4 times 5 is 20. So I could just do 10,000 times 1 plus 0.08 divided by 4, close that parenthesis, and then raise 2, and then put 20. Or if you want to do 4 times 5, you could. All right, and so we found that our ending amount is 14,859 point, and we're talking money, so we're only going to go to 2 decimal places. So it was 47, it's a 3 there. That 3 is going to make that 7 stay the same. And so there is our solution. Now, the more times it's compounded per year, the higher our answer is going to be, okay? So if it said it was compounded monthly, we'd make a little bit more. Is it going to be a huge amount? Usually it's not too big of an amount, unless that 10,000 was maybe like 10 million or something. You know, the larger your beginning balance, the more difference you'll see between them. But typically, the larger the compounding, the larger the answer will be, but not by a whole lot, okay? And so we'll see that here in example 3, because we're doing the same problem, except now the last sentence says find the balance in the account after 5 years subject to continuous compounding. That means it's just continuously being compounded, and that means we're going to use that second formula. So we're going to use what I call the PERT formula. A equals PE raised to the RT. Again, it says a sum of $10,000 is invested, so that's our principal. That's what we're beginning with. And an account invested at an annual rate of 8%. So rate is 8%. Divide 8 by 100, we get 0.08. Find the balance in the account, so we're after the ending amount, after 5 years, when continuously compounded. There's no N in this one. All right, so let's plug in what we know. A equals 10,000 times E raised to the R, which is 0.08, times T, which is 5. And you could actually multiply, go ahead and just multiply those two together if you want to. You could say it's the same as 0.4. And then type it in. And so we got 14,918 point. It's 246. That 6 is going to make that 4 round up to 5. And so there is our answer. So you'll notice it's not way off of the other answer. It's only about, what, 50, 60 bucks more. So it's a small difference, but it is a little bit higher because it's being compounded more times. It's continuously. All right, and that is the end of 4.1.